Students, in today's lecture, we will discuss the discrete time convolution problem. Uh, this is the given problem y of n equal 1 by 4 whole power n u of n. This is convolution symbol with u of n plus 2. We are supposed to find the what is the resultant equation by using the convolution sum. So to start with, in general, we know the equation for convolution sum is y of n equal k minus infinite to plus infinite x of k h of n minus k. Let's say the given signal x of n is 1 by 4 whole power n u of n and h of n is u of n plus 2. So we are supposed to find the convolution between x of n h of n. Okay, now by using this equation, okay, now we are going to write y of n equal summation k equal minus infinite to plus infinite. So we are going to change the index of n to k in x of n. So since this is x of k, we are changing the index 1 by 4 whole power k u of k. And we have h of n minus k, we have h of n. So we are going to delay the n by k samples n minus k. So we obtain u of n minus k plus 2. Okay, so whenever we solve problems using convolution either in discrete time or continuous, we are very careful about the limits, how this limit affects will be affected by x of n and h of n. Okay, so we'll depict through some graph. Okay, let's say we have u of k signal. Here we have three terms, 1 by 4 whole power k and u of k, u of n minus k plus 2. So how these two terms, that is u of k and u of n minus k plus 2, affects the limits, and we'll apply the simple formula. Let's say we have signal, this is u of k and the index is k. This is unit step signal u of k. Okay, and what is this? This is u of, this can be written as u of n plus 2 minus k. Okay, so first we have to write u of minus k. What is u of minus k is this, 0 minus 1 minus 2 minus 3 minus 4. And what about u of minus k, u of n plus 2 minus k? The signal will be like this, and the upper limit will be, so this is the index k, this is k, and the upper limits will be u of n plus 2. Okay, 0 and up to etc up to n minus 2. We don't know what is n, but this is the graphical representation of u of n plus 2 minus k. Now coming back to the equation, here these two terms u of k, u of n plus 2 minus k, if similarly here if I multiply these two terms, the resultant graph will be like this. It starts from 0 1 2 up to 1 2 up to n plus 2. The other places will be 0 because we have 0 here, u of minus k, and from 0 to n plus 2 only the signal is present in u of n plus 2 minus k. Similarly here, so less than 0 the signal will be 0, so the total signal will be like this. So now the limit is changed from summation k equal, what is the lower limit? The lower limit is 0. What is upper limit? Upper limit is n plus 2. Okay, and 1 by 4 whole power k. Now we apply the standard formula. What is the standard formula? The standard formula, I'll write the formula here. You can apply whenever the question is asked in convolution, discrete time convolution. You can use this formula. Summation n equal, the lower limit is n, upper limit is capital N, and a power n. Okay, so we use the formula a power upper limit minus, sorry, lower limit minus upper limit plus 1 divided by 1 minus a. So this is the case where a is not equal to 1. So this is a. If a is not equal to 1, we use this formula. If a equal 1, we apply simply the upper limit plus lower limit minus 1. That we know the standard formula. That is n minus upper limit minus lower limit plus 1 if a equal to 1. Okay. If I apply the same concept over here, here a is not equal to 1. So I use here a equal to 1 divided by 4. So I use 1 by 4 whole power 0 minus 1 by 4 whole power n plus 1. What is n here? Here n is n plus 2. So n plus 2 plus 1 divide by 1 minus a. What is a? 1 by 4. So now the answer is 1 minus 1 by 4 whole power n plus 3 divide by 1 minus, sorry, this can be written as 3 by 4. So therefore y of n equal 4 by 3 multiplied by 1 minus 1 by 4 whole power n plus 3. Now this is the answer for convolution sum. Clear? Thanks.